You don't go online, you route. Every time you open a website, your request doesn't travel through a single internet. It travels through a patchwork of competing networks, thousands of them, owned by telecoms, cloud companies, governments, universities, and businesses. And there's a system that decides which path your traffic takes. Not inside your device, not inside your router at home, at the level of the internet itself. And if that system makes the wrong decision, even for a few minutes, huge parts of the web can vanish. Not because cables were cut, because the internet got lost. This is the unseen system that routes the internet's traffic. Most people imagine the internet like a highway system run by one authority, but it isn't. The internet is more like a world map made of private roads. Each big network is its own territory, an autonomous system. An autonomous system might be an ISP, a mobile carrier, a major company, or a cloud provider. Inside their territory, they control everything: routing, equipment, policies, priorities. But the moment your traffic needs to leave one network and enter another, a new question appears. Which network do we go through next? And the internet can't solve that with a central map, because nobody owns the entire map. So the internet uses negotiation. Networks announce what they can reach, and other networks choose which announcements to trust. That negotiation system is called BGP. BGP is often described as the protocol of the internet. But here's the simplest way to think about it. BGP is the system that tells networks which paths exist. It doesn't move your data, it decides where your data should go. Every network tells its neighbors, I can reach these IP ranges. Those ranges are called prefixes. So a network might announce, I can deliver traffic to these addresses. Then neighboring networks pass that announcement along, like relaying a message across borders. Over time, thousands of these announcements form a living map of the internet. But it's not a map based on geography, it's a map based on relationships. Who connects to who pays who trusts who. And because the map is built from announcements, it can change fast, sometimes too fast. Here's the part almost nobody realizes. Routing decisions aren't only technical, they're economic. Most of the time, networks choose routes based on relationships like these. Customer. One network pays another to carry traffic. Provider. A bigger network sells access to the rest of the internet. Peer. Two networks agree to exchange traffic directly, usually to save money and reduce latency. These deals shape which paths exist, and they shape which paths get preferred. So the internet isn't always choosing the shortest route. It often chooses the route that matches policy and cost. That means your traffic can take a longer path because it's cheaper, or avoid a path because of business agreements, even if physically it's closer. BGP is where those policies become reality. The uncomfortable part: BGP doesn't work like GPS. There is no central authority checking whether a route announcement makes sense. No global system verifying that a network should be announcing what it claims. Each network makes its own decisions based on local rules. And once a route is accepted locally, it can spread outward, network by network, until it becomes part of the global map. That means the internet doesn't ask, is this route correct? It asks, do I trust the network that told me this? And trust at this level isn't emotional, it's operational. If a network has been reliable in the past, its announcements are more likely to be accepted. Which means a single mistake made by a legitimate operator can propagate faster than anyone can react. Not because the system is broken, but because it's doing exactly what it was designed to do. Because BGP is built on announcements, a single bad announcement can have outsized impact. If a network accidentally announces routes it shouldn't, other networks may believe it. And suddenly, traffic that used to go to the correct destination starts flowing somewhere else. Sometimes it just drops. Sometimes it gets black-holed, sent into a network that can't deliver it. In the worst case, traffic can be hijacked, rerouted through a place it was never meant to go. And this doesn't require breaking encryption. If you can redirect traffic, you can disrupt services. You can slow things down. You can create outages that look like the site is down, when really the route is wrong. The internet can be perfectly healthy and still unreachable because the directions are broken. The uncomfortable truth is that classic BGP has very little built-in verification. It was designed in an era when the internet was smaller and trust was assumed. So when a network says, "I can reach these addresses," neighbors often accept it. That doesn't mean hijacks happen constantly, but it means the system's default posture is fragile. And when mistakes happen, they can spread quickly because announcements propagate. It's like a rumor that becomes official because enough people repeated it. A route hijack can be accidental, or it can be intentional. Either way, the mechanism is the same. A wrong path gets advertised, and the world starts taking it. So why not just secure it completely? Because BGP isn't one system controlled by one group. It's the treaty layer between thousands of networks. Any improvement has to be adopted across competing organizations, different countries, and different business incentives. There are modern protections. Operators filter routes, they enforce policies. There are frameworks like RPKI that help networks verify who is allowed to announce certain routes. But adoption is uneven because security is a cost, and the internet still rewards speed and compatibility. So the internet keeps running on a system that works remarkably well and fails in ways that can look like magic. Most people think the internet is always there, but the internet isn't a place, it's an agreement, a constantly updated set of directions shared between networks that don't fully trust each other. BGP is that agreement. And when it goes wrong, the internet doesn't explode. It simply stops knowing how to reach what you asked for. If you want to understand the hidden infrastructure that quietly shapes everyday life and what happens when it starts to fail, subscribe to Unseen Systems, because the most important systems are rarely the ones we're taught to see.